Okay, so today we are having a topic that is pancreas. So, first of all, let's understand that what is pancreas. Pancreas is a gland. It's a gland. It's a heterocrine gland. What does it mean? It means that it is having both part, exocrine and endocrine, means the duct part and the without ducts part. Okay, so this is a gland, okay, which is attached with the duodenum, and this is also you can say that this is having a main role in the digestion in the small intestine. So their secretion is important in the digestion. So first of all, we were discussing about the parts. Then I'll be telling you that what are the enzymes, what are the parts, what from where the pancreatic juice, which is important in the digestion, where it is from where it is releasing, and what are the things that is present in the pancreatic juice. So we will be discussing all that. After that, come to the point. So here you can see that this is what, this is the body of the pancreas. This is the structure of pancreas. This is the body of the pancreas. Okay, and this is, you can say, this is the tail of the pancreas. Okay, and this is the interlobular duct. Okay, and this is the head of pancreas. Okay, and this is a hepatopancreatic duct. Hepatopancreatic duct, which consists of two ducts, hepatic duct and a pancreatic duct. So that is in the combination form, that is called the hepatopancreatic duct. This is all things I have told you guys before that. This is duodenum. You can see that how the pancreas attached with the duodenum. Okay, and here you can see that here the gallbladder duct is there, and here the hepatic duct is there, and here their own duct is there, which is a Wirsing pancreatic duct, or you can, and this is what, this is a common bile duct. Common bile duct, which is consisting of the, you can say that the common bile duct is consisting of what, they are consisting of the ducts. Okay, they are consisting of the ducts. So this was the structure of the pancreas. So as you guys all know, what is common bile duct? So common bile duct is a duct which is consist of the cystic duct, which is a gallbladder duct, as well as the hepatic duct, where the bile is coming. So the combination, we are calling them as the common bile duct, which is coming from the liver. Okay, so this was the structure of the pancreas. Now if you're talking about this part, so I have magnified this to view that how this is heterocrine gland. So this part is the exocrine, and this part is a, you can say that this part is a endocrine. Okay, this part is exocrine. They are having ducts, you can see that these ducts, and they are having no duct. So this is endocrine part, so they are having both parts. Okay, so this is a major duct of pancreatic duct. Okay, this is a major pancreatic duct, and this is a duct which is called the interlobular duct, which we have discussed here. Okay, this one duct. Now if you're talking about this duct, so this is called, these both duct, this is called the intercalated duct. So intercalated duct will release the bicarbonate ion. Okay, and their cells will be just the cells of the you can say the calated duct, which is enteroechiner cell. So they will be, you can say that the stimulate by the secretin hormone, then it will be releasing the pancreatic juice. Many students did the mistake that the pancreatic juice is secreted by the echiner cells. These are cells of the pancreas. So no, the echiner cell will not release the pancreatic juice. So the intercalated duct will release the pancreatic juice. It will release the enzymes, which are the enzymes that the pancreatic amylase, pancreatic lipase, pancreatic nuclease, that I will be telling you in the summary. And but this will release the bicarbonate ion, and this is what, this is the structure of Iles of Langerhans. Okay, so this is what, these are the alpha cell, I'll be discussing that what's the function of these all. This is alpha cell, this is the beta cells, and this is what, this is the endocrine part. Okay, these are what, this is the blood vessels, these are the blood vessels, and here you can see that these are the delta cells. So there are three important cells, but we are having fourth one too, which is FFP cell, which is pancreatic lipase. So that we'll be discussing too. But before that, let me tell you that what's the, you can say that what are the enzymes that will be working here. So we are having many enzymes. So intergalactic duct, which is consist of the centroechiner cells, which will release the pancreatic juice. Okay, this centroechiner cells which are present in the intercalated duct. Okay, so they are, you can say that in there the lumen of echiner are present. Okay, so this is also called the principal cells. Okay, and this is released what, bicarbonate ions and mucus, you can say that. And this intercalated duct is stimulated by which hormone to release the bicarbonate ion? That is the secretin main, as well as acetylcholine, which was, as you guys all know, in the stomach that was a neurotransmitter, and this is also the neurotransmitter. Okay, so that these cells, or you can say the duct were stimulated by which hormone? Secretin and the this one. As you guys all know, I have told you the function of the secretin. Okay, so if you're talking about the echiner cells, so we are done with this this intercalated duct which releases the bicarbonate. Now let's talk about the echiner cell. So echiner cell is basically stimulated by which, you can say that the this was stimulated by the acetylcholine, and you can see the cholecystokinin. Okay, as you guys all know, in cholecystokinin was also, you can say that stimulating the gallbladder to release the bile, where the bile is stored of the liver. So on that was also working there, but here you can see that in a echiner cell will stimulate by the acetylcholine and the cholecystokinin. So they consist of three, you can say that the enzymes. As you guys all know, I told you guys that echiner cells contain the enzymes which are local enzymes that were in the small intestine too, but here there are enzymes too. There is pancreatic lipase. Okay, these are the enzymes of pancreas. That's why we are here writing here the pancreas. Okay, not pancreatic, this is nuclease. So lipase will convert into glycerol and fatty acid. Okay, so the pH of this enzyme is 7.8 to the, you can say that the 7.8 to 8.5, 7.8 to 8.5, and this is what, this is amylase, which will work in the which will work in mouth too. So this will convert into the, you can say that the starch. Okay, so this is 6.7 to 7, and they are having a 8 to 9. Okay, so these were what, these are the enzymes of the which are present in the echiner cells. Now if you're talking about the exocrine part, exocrine part, we are having exocrine part. Which one is the exocrine part? As you guys all know, I told you guys exocrine part. So these exocrine part is also consists of the proteolytic enzymes. Proteolytic enzymes. What does it mean? It means these are the enzymes which actually break the protein that is released by the echiner cell. Okay, function I will be telling you. So the proteolytic enzymes, peptidases. Okay, so as you guys all know, we were having a endopeptidase and exopeptidase. So this is endopeptidase. Okay, so what are the function of the endopeptidase? As you guys all know, so the function of this endopeptidase was that endopeptide was the that will break the amino acid bond from the long part to the smaller parts. Okay, and you can say that this will be happen where this will be the this will happen in the pancreas. Okay, so this was antipeptidases. So in antipeptidases we are having two, you can say that hormones, which is the no these are the enzymes, sorry, this is the enzyme trypsinogen. These are the main hormone, trypsinogen and chymotrypsin. So this is the inactive form of the, you can say that, the enzymes. So chymotrypsin will active by the, you can say that, enterokinase, which was the enzyme and which was released by the duodenum, as you guys all know. So that will be stimulated by the trypsinogen and converted in an active form, that is trypsin. If we're talking about the chymotrypsin, so that will be also active by the trypsin, where it become the active form. So it will get active to the chymotrypsin too. So it will be trypsinogen, not trypsin, sorry, trypsinogen will convert by the trypsin into the active form, which is chymotrypsin. This was what chymotrypsinogen will be converted by the trypsin and move to the active enzyme, that is the chymotrypsin. Okay, this will work in the duodenum. Okay, if you're talking about the pH, so the pH of this chymotrypsin is 8 to 9 pH, and if you're talking about the trypsinogen, so they are having a pH that is 5.2 to 6.0. Here you can see that the enterokinase, as well as you can say that enteropeptidases can also stimulate that. Okay, so now if you're talking about the exopeptidases, here we have discussed about endopeptidases, and here we are learning about the exopeptidases. Okay, so if you're talking about the function of the endopeptidases, so as you guys all know, the function of exopeptidases was that break the terminal which are present in the amino acid bond, and okay, amino acid from which the amino acid will, you can say that the free amino acid will release from, you can say that, to make the bond, to break the bond. Okay, so we are having two, you can say that the here we are having two enzymes. Okay, so that is the procarboxyl peptidases and proamino peptidases. These are the inactive form of the enzyme. That all these both will be converted into active form by which, that is trypsin. They'll be converted into the carboxyl peptidase and amino oxypeptidase. Okay, so that will be also released by the echiner cell, and that will be also released by the echiner cell, which is having the exocrine part, which is are having a echiner cell, though these both will be released by the echiner cells, and this will release in the echiner cell, but they will work in the duodenum. Okay, they will work in the duodenum. Now if you're talking about the endocrine part, So as you can see here, we have discussed about that the exocrine part, the you can say that the exopeptidases enzyme and the endopeptidases. So this part is finished now, and we have discussed echinate cell, this all. Now let's talk about the Isles of Langer. Okay, Isles of Langerhans. So let's discuss about this. So I'll be telling you alpha, beta, delta, and this one. Okay, so this all. So Isles of in endocrine part, the Isles of Langerhans consist of alpha glucagon. So glucagon is basically released when the sugar level is high. Sugar level is high. No, sorry. The sugar level is low. Sorry, I thought it's insulin. Okay, so this is the that will release when the sugar level is low, and they will activate by the Brunner's gland. As you guys all know, in small intestine there was in submucosa there were the Brunner glands. Okay, so they will be activated by the Brunner's gland. For example, you can say that by the they have in glucagon we are having the two process, that is glucolysis and glucogenesis, which were converting glucose into the glycogen and glycogen into the glucose. So this is what, so here you can see that this is the blood capillaries, and this is happen when they will release when the sugar level is low. If you're talking about the insulin, which is the beta cells production, this was the alpha cell production. So insulin is released when the sugar level is high. Here the glucagon is released when the sugar level is low. Here it will release when the glucagon level is high. Okay, so as you guys all know, glucagon always is stored in the liver cells, muscles. Okay, so with that, the high amount of sugar in the body will cause the diabetic mellitus, as well you can say that hyperglycemia. Okay, in which the glucose will not convert into the glycogen. Okay, glucose will not convert into the glycogen. This is happen when the high production of you can say the glucose is, which is in our body. Okay, so now if you're talking about the delta cell, so delta cell basically having, the delta cell is basically somatotropin hormone. Okay, somatotropin hormone. Okay, so what does it mean? It means that it work for the stimulating hormone, somatostatin hormone, which work as a stimulating hormone, means it will stimulate the alpha cell and beta cells. Okay, so you can say it will work as check and balance. Okay, and they will prevent over releasing of the pancreatic hormones. Now if you're talking about the fourth one, that is the pancreatic polypeptide, or you can say that as a PPF cells. They will release uh, they will work to release the pancreatic peptidases, which is having a exo and endocrine endo 2. Okay, so they will what, they will activate the enzymes. These will activate these cells, but this will activate the enzymes that we have discussed, is the endopeptidases and exopeptidases. So they will, you can say, that activate the enzyme, and they will also work as a check and balance. Now if you're talking about the pancreatic juice, pancreatic juice consists of the bicarbonate ions, which is released by the intercollected duct. Okay, not a echinate cell. So pancreatic juice, which is secreted, that is about 200 to 800 ml pancreatic juice is released each day. So you can see that pancreatic juice is releasing out from where, from this duct. Okay, so this was about the structure of pancreas and the hormones which are present in the exocrine part, which was enterokinase and not enterokinase, endopeptidases and the exopeptidases. And we have discussed these all, alpha, beta, delta, and this FFP cells. So this was about today's topic.